All right, for today's video lesson, we're going to be working on finding probabilities of simple independent events. Okay, so we can use diagrams and tables to help us kind of organize all of the possible outcomes for depending on what kind of events we're looking at. Okay, so what we're looking at right here is a tree diagram. All of the outcomes that could occur if we're combining the probabilities of a head or a tails, or all of the possible outcomes for a dice, right? So when we're building these tree diagrams, it's easiest to make sure that we do our least, the outcome that has the least opportunities first. So if we're flipping a coin, obviously there's only two outcomes there, right? Heads or tails. But if we're rolling a die, there are more outcomes there. Okay, so it's just going to be a little bit easier for us to do the event that has less outcomes first. Okay, but if you went to do it the other way around, it would not be wrong. Okay, it's just going to make our lives a little bit easier. Okay, and yeah, tree diagrams are useful because it shows us all of the possible outcomes for those particular events. Okay, so it's going to help us when we're asked for what is the probability of, for example, flipping a head on a coin and rolling a 2. Well, the probability, if we look at all of our outcomes here, there's only one outcome that shows a head and a 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the P of flipping a head and rolling a 2 is equal to 1 in 12. Okay, so it makes it a little bit easier to identify what is the probability of one particular event occurring. Okay, so for this example here, there is a play at a school. There are 3 doors on the stage and 2 back doors. So during a school play, each character will enter through one of the 5 doors, and the next character to enter can be either a boy or a girl. It doesn't really matter. Okay, so as what we have to do here, we need to draw a tree diagram to show the sample space. Okay, so remember, we want to do the event that has the least amount of outcomes first. Okay, so the first is going to be gender. Oops. So the first is going to be gender. And of those options, we only have a boy or a girl. Okay. This is just the start, I guess, of the probability tree. Okay. So what are the options? What are the doors that the boys or the girls can go through, right? Well, we said that there were 3 doors on the stage and 2 back doors. Okay, so for the doors on the stage, we can further break those down to be center, right, and left. And the back doors can be left and right as well. Okay, so we'll start with the gender, and the next outcome that has more than just the gender will be the door that the person enters in. So the boy could either enter through the back left door, he could enter through the back right door, he could enter through the left stage door, the center stage door, and he could also enter on the right stage door. Okay, so the same thing for the girl. She's going to have the same possibilities on what door they will enter on. Okay, so back left, back right, center stage, left stage, and right stage. Okay, make sure you draw lines to each outcome. Okay, it's just going to allow us to kind of trace that a little bit easier. Okay, so now that we've showed our sample space through a tree diagram, this shows all of the possible outcomes that could occur. So now the question is asking us, what is the probability that a boy will enter through the center stage door? Okay, so we can follow that. So of our possible outcomes, we have 1, 2, 3, 4, 5, 1, 2. So 6, 7, 8, 9, 10. Right? We have 10 possible outcomes there because it could be a boy entering through one of the 5 doors or a girl entering through one of the 5 doors. So the probability of a boy entering through the center stage door, that is going to be right here. And there are only one of those possible events. So the probability of a boy separated by the comma, that just shows that there's 2 events entering through a center stage door is equal to 1 in 10. Okay. So that's our actual answer as a fraction. As a percent, we'll just divide 1 divided by 10 is equal to 0.1. And if we multiply that by 100, we will get 10%. So the probability that a boy will enter through the center stage door next is 1 in 10, or a 10% chance of that occurring. Okay. So the second example here, we are using a table to determine the probabilities. Okay, so we're not going to use the tree diagram for this example. So we have a marble being selected out of a bag and a 4-sided die being rolled. Okay, so the marbles could either be blue, red, or green. Okay, and then we have a die which could be 1, 2, 3, or a 4. Okay, so now we're going to show our sample space in here. So the first possibility is be pulling a blue marble and rolling a 1. Second probability of pulling a blue marble and rolling a 2, blue marble and a 3, and blue marble and a 4. And again, we use the comma to separate the 2 events. Okay, the fifth possibility would be pulling a red marble and rolling a 1, red marble and rolling a 2, red marble and a 3, and a red marble and a 4. Okay, lastly, we'll have green and 1, green, 2, green and 3, and green and 4. So now that we have the table filled out, it's going to be a little bit easier for us to answer the probability of whatever event it's asking for. Okay, so in this question, it is asking what is the probability of choosing any number or of choosing any color and rolling any number but 3. Okay, so we're just looking for anything to occur except for rolling a 3. Okay, so this would be okay. That's okay. That's good. Good, good, good. 3s, we do not like that column because we do not want to roll a 3, but this column is good as well. Okay, so we have 9 favorable outcomes. So first we'll say P, any color, any number but 3 is going to equal, we said there are 9 favorable outcomes. And if we count up all these possibilities, there are going to be 12 possible outcomes. Okay, so that's as a fraction. If we wanted to write this as a percent, 9 divided by 12 multiplied by 100 is 75%. So pretty good odds that that event would occur. Okay, next question. What is the probability of pulling a blue or a green marble and rolling a number greater than 1? Okay, so probability of blue or green. So, and rolling a number greater than 1. So we cannot have any of the possibilities in the 1 column because we want to roll a number greater than 1, and only a blue or green marble will work in this case. So blue 2, blue 3, blue 4 will work, and green 2, green 3, and green 4 will also work. Okay, so we just counted up to 6. So P, blue or green, number greater than 1 is equal to 6 over 12. Okay, 6 divided by 12 multiplied by 100 is 50%. And that's it for C. Okay, 2 questions to go here. So part D is asking, what is the probability of pulling a black marble and rolling a number 1? Well, if we look at our chart, a black marble isn't even in the option, right? So there's no way that we're going to be pulling a black marble, okay? So probability of a black marble and rolling a 1 is equal to 0 out of 12, or 0%. That event cannot occur. Okay, question E, sorry, I didn't have that in there. Okay, so question E, what is the probability that a red or green or blue marble is selected, so any color, and the die displays a 4? Okay, so it's asking, what is the probability that a red, green, or blue marble is selected and the die displays a 4? So in that case, the die needs to have a 4, and it can be any color. So we'll have one event here, one event here, and one event here. Sorry, one event here, one here, and one here. So that is 3. So the probability of a red or green or blue marble and rolling a 4 is equal to 3 over 12. And as a percent, that will be 25%. Okay. For our next question, we have we're flipping a coin and we are spinning a spinner. Okay. So like we said earlier, when we're setting up a tree diagram, we want to do the event that has the least amount of outcomes first. So that's going to be the coin. And we can have either, so we're rolling a coin and we're also rolling a spinner. Okay, so for our coin, we can either get a heads or a tails. And from that heads, it can either be a hat, coat, shirt, or pants. And same thing for tails. Hat, coat, shirt, pants. So now if we look at this, this will tell us all of our possible outcomes. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 possible outcomes. So that will be our denominator. And the question is asking us, what is the probability of flipping a heads and getting a hat or a coat? Okay, so heads is up here. And then it's asking if we get a hat or a coat. So there's 1, 2 events there. So probability of heads and spinning a hat or coat is equal to 2 over 8 or 25%. Okay, so hopefully that makes sense to you. The assignment associated with this lesson is the 5.3 worksheet. Okay, I would like you guys to complete that today or over the course of the weekend. We don't have math on Friday, yay. Okay, but I'd like you to complete this and bring it in and hand it in on Monday, where we return to classes. Yay. All right. So if you have any questions or need any help, please send me an email. I'd be more than happy to help you. And other than that, have a wonderful day.